Hi, my name is Matt, and for subscribers to the channel, you know today is kind of an exciting day. This video will actually be the official launch of the Diagnosis and Understanding series. There will be other videos in this series already that I've kind of put into the playlist, but this is the result of some of your feedback and ideas to kind of put the channel in a new direction, which we talked about in the previous video. Let me go ahead and take care of one thing on this video. Of course, we're going to learn about the throttle position sensor. There are going to be a number of new people that come to this channel for the first time through this video, because you guys who are here for the first time almost certainly are here because you have a check engine light, and it is in the format of P012X, where X doesn't matter because you are convinced, because throttle position sensor is in that check engine light code, you want to learn how to replace your throttle position sensor. And in that case, you are in absolutely the right place, but not for the reason you think. If you think I'm going to show you how to replace a throttle position sensor on this channel, you are sadly mistaken. So goodbye to 98% of you right there. But for those of you that are hanging on and you don't want to learn about the sensor and understand why, 90% of the time when you have a code on a throttle position sensor for your check engine light, the throttle position sensor will not be the problem. If that isn't good enough for you, then here's what you need to do. Look on any of the suggested videos that are either to the right or underneath me in your screen and just click on any one of them. It doesn't matter. And in that video in 3 minutes, you will learn how to remove the 2 screws and 1 electrical connector because you couldn't figure out to do that yourself, and then how to improperly reinstall a new throttle position sensor, because they're not going to tell you that there's actually a little trick to it that most people don't know. You have to calibrate it. And then when you do that and you still have your check engine light come back on, then come back to this channel and maybe you will be able to join the 2% of people in the universe that would have known not to change the throttle position sensor and waste their time and money in the first place. So if that sounds interesting, hang along. For you guys that know what's coming up next, let's get started, because this thing has a lot of potential. Ha! Get it? Potential. The throttle position sensor, it's a potentiometer. All right, so of course we are going to learn exactly what the throttle position sensor is, how it works, its responsibility in engine performance management, and then we will apply the theories to an actual car, and I will show you various ways how to test and diagnose a throttle position sensor and look for proper or improper operation using various methods, from a scan tool down to a regular digital volt ohm meter, which I know most of you guys rely on. And I will also promise in the future to try to include non-scan tool based testing methods for those of you that don't have a scan tool. But again, at this stage, if you're a regular subscriber on the channel, you might want to invest in even just a couple $100 scan tool, because if nothing else, to get your fuel trim measurements and things, which is mentioned in another video, that alone is going to get you 90% of your diagnoses started off in the right direction right there. I'm going to assume you know how to use a digital volt ohm meter, by the way. This is a bit more of an advanced channel, so you wouldn't walk into a physics class and ask the professor when he's talking about friction measurements with W sine theta how he was doing the division. You would just be assumed that you've learned that previously. So if you're looking to learn how to use your DVOM for the first time, you should go elsewhere, but then maybe come back. Anyway, throttle position sensor. So one of the main things that most of you guys are familiar with an engine, let's draw an engine here. And again, my awesome artistic abilities are going to come through again. It's almost like a Steven Spielberg film with the special effects. We will have air coming into the engine. This, of course, would be the exhaust. Generally with an O2 sensor, which I talk about extensively in the fuel trims video. Very important to understand that, because all other sensors in the car are in some way interconnected, and we'll talk a little bit about that. But it's important to realize that the throttle position sensor isn't just out there on its own. No sensors for an engine are out there on their own. They're all connected somehow. But the main thing is, when you get air into the engine, you of course are going to have to add fuel to the engine as well, and it's going to be in what's called a stoichiometric ratio. I know most of you guys have seen me do this ad nauseum. 14.7 to 1, 14.7 parts air to 1 part fuel. If the engine is going to do this, it is essential, of course, that it knows how much air is coming into that engine. Otherwise, how can it possibly know how to make the fuel mix? And there are various ways that the engine does this, many of which we discussed before. In the previous video, we talked about the map, and then indirectly in some other videos, like the intake air temperature diagnosis video, and also in the fuel trims video, we talk about the mass airflow sensor, which also helps to measure how much air is coming in. But there is also this other way, and that is with the throttle position sensor, or TPS, which basically measures the angle of your throttle. When you step on the gas pedal, you are, of course, really actually stepping on the air pedal. The gas pedal is going to move the throttle open, and when you let go of the gas pedal, it's going to close it. And basically, the throttle position sensor is a potentiometer, I will explain that, which measures how open or closed this throttle is. Obviously, the more open the throttle is, the more air that is going to come into the engine, and the throttle position will be taken into consideration for the calculation of how much fuel to add based on how open the throttle is. And of course, there's those other input sensors used as well, but this is part of them. So let's go ahead and take a closer look at exactly how the throttle position sensor functions, and then we will be able to understand how to do testing on it to verify that it works properly. All right, so here is our throttle here in green, and then we will put right here our throttle position sensor, our TPS. So what happens is, on your typical TPS, and some of them, a lot of times can be different than others, but in general, if you understand this concept, then it's going to apply in one way or another to pretty much any potentiometer. And the idea is, we are going to have, if we take a look at this TPS up close, there are going to be generally 3 wires coming off of it. One wire is going to be a 5-volt reference, a 5-volt signal coming into the TPS. There is also going to be a signal wire here. We're going to put SIG here. And that is going to be output to the PCM. And I'm going to kind of simplify this a little bit. I know there are some guys that are going to really be a little more touchy on the accuracy of this. And I'm going to leave that to some other, engineering type channels to talk about. Basically, the idea is, if you get the concept of how this works, it's really not necessary to understand the specifics of how the PCM delivers the signal and all this stuff. And then, of course, you're going to have a ground. So the way this works is, for all practical purposes, the throttle position sensor is a variable resistor. And it is a special one called a potentiometer. A potentiometer will vary resistance based on a change in position. So as this throttle opens, what is going to happen is, there is going to be a voltage from this 5-volt reference to the signal wire. The more open the TPS is, then the more voltage that will go through the signal wire. And of course, the PCM detects these changes in voltage and knows to adjust the injector pulse length appropriately to adjust the fuel mixture. So it goes without saying, one of the first things you would want to do in diagnosing any throttle position problem is, do you have 5-volt signal? Do you have ground? And is there variance in the voltage through the signal as you change the potentiometer angle? So that is what we are going to go ahead and show you how to test on this car here. And then we will come back and talk a little bit more about some diagnosis and some other things. And we are going to go ahead and test our theories on this 2000 Trans Am WS6, which some of you may have immediately recognized in the video. Actually, maybe some of you haven't. Okay, there you go. If any of you guys drive rice burners, then now I'm sure you recognize this view of the Trans Am. Yep, your mom definitely had it right. Eating rice every day keeps you big and strong. All right, and if you have to be shown where your throttle position sensor is, then I'm going to tell you things aren't boding too well from you right now, because based on the operation description, you would figure that the throttle position sensor must be connected directly to the throttle. So here is my throttle right here that I can move back and forth. There's a pin going through the throttle body to this guy right here. So that must be the throttle position sensor. You should be able to find the throttle position sensor on any car because you understand how it works. So what else could it be? And incidentally, above it here, this is going to be an idle air control, and this is going to be mass airflow sensor, and also an IAT here, which we will talk about in future videos, and actually have talked about indirectly in some other videos. But this is where we're interested in right here. Now, what we're going to do is, before we start breaking out the voltmeter and playing around with that, we're going to go ahead and hook up the scan tool so that we can revisit how the voltage responds to changes in the potentiometer. All right, so what I've done is hooked up a scan tool here. Do not worry if you don't have a scan tool. We will show you some other ways to test it, although honestly they're not going to be nearly as accurate as a scan tool or an oscilloscope would be. But basically here is our throttle, and we are using the scan tool to detect voltage in the throttle position sensor. The engine is on, of course, right now. It's not running. We do not need it running for this. The throttle position sensor is active with the engine on. And we are at 0.5 volt right now, representing that there obviously must be the maximum resistance going from the 5 volt reference to the signal. And as I move the throttle position, you can see that more voltage goes through the signal wire. So as I'm moving the throttle position sensor and changing the angle of the throttle, the potentiometer responds, because as I move, I'm reducing resistance through the potentiometer and allowing more voltage to travel through the signal wire to the PCM. Now, what we would look for is, of course, that we have, first of all, a response. The very fact that I have a response tells me my electrical is good. I have a 5 volt reference signal coming in. I must have a good ground, and I must have a good signal wire because I'm seeing differences. The fact I'm seeing differences also is some indication that the throttle position sensor itself is working. But there are some problems that you can have that you would want to test for. So one of them obviously would be if I saw no voltage coming in, I would be inclined then to unplug the sensor and test to see if I have a 5 volt signal. If I do not see any variation with the sensor, I'm going to be concerned that I have either a bad ground or some disconnection with the signal wire, and we'll talk about that soon when we do the DVOM tests. But the main test that I want to do now, knowing that this works, is verifying that I do not have any dead spots in the throttle position sensor. So what I want to do is go real slow and look for a smooth increase all the way open, and you can see that are all the way open, we're at 4.5 volts, and then come back down just as smooth. You want to go fairly slow here to give time for the scan tool to get the data. Some cars are a little bit slower at sending the data to the scan tool than others. And we see that we had a smooth transition, and I could easily feel that the relationship between the throttle angle and the voltage seemed consistent. So one of the things that you may find that would cause often a hesitation when you're hitting the throttle, like if you're coming off of a stoplight or something like that, is you may see dead spots. You may move up and then you'll see a dead spot, maybe even a couple of them. And then you would also see them, of course, on the way back down as well in the same positions. And what would happen in these dead spots is the computer is going to think that you let off on the gas pedal there when in fact you did not. When it thinks you lit off the gas pedal, of course it is going to reduce fuel delivery when it still needs it, a lean condition. And of course a lean condition is going to cause the engine to stall out. So that is one symptom that you may look for. Now, let's look at some tests that we could do with the digital voltmeter if you don't have a scan tool or if you need further diagnosis. All right, for our DVO measurement, you know what, let me actually just go ahead and get rid of some of these other connections here just to make this a little bit easier to see here. So there's a couple things I wanted to mention before we do these tests. Two things. First of all, if you noticed on that scan tool, and we will also repeat it with the DVOM, you'll notice that the baseline voltage was 0.5 volts and that the maximum wide open throttle voltage we saw was 4.5 volts. So this is important to know because on most throttle position sensors, when you reinstall them, you can actually, when you loosen the bolts up a little bit, you can rotate the throttle position sensor, which of course, if you rotate the sensor, is going to alter that voltage. And there will be a specification, I've seen it from 0.1 volts to, in this car, 0.5 volts, where when you reinstall a new sensor, you will want to position it so that at closed throttle, you have that specification of volts and you fasten it in that position. So in other words, you can't just replace the throttle position sensor and bolt it in. But now you know. The other thing too to notice is if you have the good responses, just like we saw there, and you're seeing changes in the voltage in accordance with the throttle position angle changes, but you notice that you have a very high voltage, maybe 1.5, 2 volts, maybe even more. Sometimes the throttle position is shown in percentage instead of voltage. So maybe 25% throttle position open. And in other words, the potentiometer is indicating that the throttle is open a little bit when it should be fully closed. Almost invariably, that is because you have a dirty throttle body, and if you clean the carbon deposits around the throttle, you will be able to get the throttle to close back to its original position without replacing the sensor. Replacing the sensor will not fix the problem in that case. You can see that with that situation and with any number of electrical problems, there are multiple reasons why you can get a throttle position sensor error code without having a bad throttle position sensor. And one of the most common codes for throttle position sensor, and also you'll see it for the IAC, the idle air control motor, is a dirty throttle body where carbon buildup is preventing the fully closed position of the component. So keep that in mind. So what I want to do is on this sensor, and as usual, you know, these get really dirty and it's hard to tell what's what. So I'm going to want to find on our sensor electrical connector here, which is my ground, which is my power, and which is my signal. So let's go ahead and do that. All right, and you know what? Actually, I am sorry, but I'm going to change my mind. The testing that we're going to do here can sometimes get a little bit dangerous because you can absolutely, if you don't know what you're doing, ground out, say, your 5-volt signal by accident without any resistance. There is the possibility that you can blow out your computer. And while I don't think that that's an issue on a 5-volt signal on this particular item here, in general, that is a consideration you want to take. So before we do the tests at the electrical connector, let me show you a safer way so that if you're a beginner and you're not familiar with what I'm doing here, we can show you a way to test this without possibly doing any destruction to your engine computer. So let's switch gears here. All right, so what we've got is a sensor removed from the car here. As you can see, this end here would just fit onto that throttle shaft, and as we turn it, you can hopefully see that it turns. And of course, as we turn, we are varying to decrease the resistance through the 5-volt and signal wire, which we do not know which is which yet, and that's okay. Obviously, the best way to do it is to use a wiring diagram, but because it's such a simple circuit here, we're just kind of hunt and peck until we find it. So I'm just going to go ahead and take a guess on 2 wires here. The good thing about this is that if I do something wrong, if the leads touch or something like that, I am not going to do any damage. So this is the safest way to test your throttle position sensor. So you may want to even do this first. If this works, your throttle position sensor is not a problem. You have a problem with the wiring or something else. You know, maybe, like I said, a dirty throttle body or whatever. But this is a great way to safely test your throttle position sensor without getting all kinky. All right, so we've got our meter up here set to resistance. And what I'm going to do is turn the potentiometer. All right, and we see we have no change in the resistance. So either this throttle position sensor is bad, or I am not connected between the 5-volt and the signal wire. I am most likely connected either between signal and ground or 5-volt and ground. Let's go ahead and put it there. And we see we've got 4,000 ohms there. Let's try turning it. All right, and now we're in business. Hopefully I'm not in the way there. God, sorry about that. Okay, so now you see as I turn, I am reducing resistance. So now I know that I am between my correct leads. So I know that one of these is the 5-volt and one of them is the signal. I don't exactly know which because the polarity doesn't matter. But I do know this. If we do this test and we find that our potentiometer is working, then if we had a check engine light code mentioning this sensor, we know changing this sensor is not going to fix the code. We need to look elsewhere. The first place I would probably look is at the electrical. So let's go ahead and look at the electrical connection. All right, and of course, it goes without saying, you absolutely can do that potentiometer test with the potentiometer still bolted in the vehicle. You do not have to remove it first. I only removed it to make it easier to show on camera, but obviously if you can get to those connections with the throttle position sensor still in place, it would behoove you to do that. You don't need the car on for that, obviously, either. But what we're going to do now to test if we have signal to the 5-volt signal to the potentiometer, it gets a little dangerous here, and I am going to strongly suggest that if you are not familiar with how to use a DVOM, or you're not familiar with the basics of automotive electricity, that you just at this point maybe either pay really close attention or really honestly get some more background training from somebody who knows what they're doing. But it's very possible if you don't have your meter configured right, you can easily see if you just got done with a parasitic draw test, even if you're a professional and you're in a configuration for measuring amperage, you have a jumper wire in your hands now. And grounding out the wrong things here will absolutely cause you to blow your computer on a lot of this type of testing. Probably not on this particular one. I'm not so afraid of it. But in general, like say it's a fuel injector connector or something like that, oh yeah, you'll blow the driver for sure. The other thing you've got to be extremely careful of is even if your meter is set to the correct settings, the leads touching when they are connected into the connector will also cause a ground out situation. Ground out the wrong things, you're going to short your computer. So we're going to go ahead and set to voltage on the meter. Let's make sure that we've got it in the field of view there. And there we go. Wow, you would think with a huge 5.7 liter engine, there would be more places to place my meter. So let's do this. Let me just put one lead right there and then very carefully put this other lead anywhere else. It doesn't matter. Okay, so I've got -4 volts. So I know now that my negative lead has to be on the power wire. So just to be sure, now I don't know if my negative is on the signal or on the ground right now, and it doesn't matter, but what I do know is that is my power wire that the red is touching right there. I know that for a fact. And also if I move the negative lead there, I also should get 5 volts. So right now, I am going to probably say that because I've got 5 volts there, I'm going to say most likely this guy is the ground, and this guy up here is going to be my signal because there's a little bit less voltage there. I may be wrong about that, but that's a pretty good direction. The one thing I do know for sure, though, I know 2 things. Number 1, that guy right there is my power wire, and that's my 5-volt power feed. The second thing I do know is that I have 5 volts going to this potentiometer. If I did not measure 5 volts on any combination of those wires, I know why I have my problem. And it is not because of a bad throttle position sensor. I have some type of problem that I am not getting a 5-volt reference. And of course, I'll have to check my wiring accordingly. But again, another example where changing the throttle position sensor would not fix this problem. So what I'm going to do now, just to make sure things are safe, is I'm going to make a red paint mark on my, what I've now determined to be my power wire. There we go. So now I know which guy is my power wire for sure. So I'm going to mark him red so I can make sure I spend extra special care not to ground him out. All right, so what I've done is I've fed some back probes into the signal wire and the ground wire. I know from my red paint mark that my power wire is up there, but what I'm really interested in is in tracking my signal wire. My signal wire that I have determined by the slight difference in resistance earlier is going to be right here. So I'm going to put my positive there. Okay, everything looks good. And then I'm, of course, going to put my negative onto the ground here. All right, and as you can see, we have our 0.5 volts right there. So as I move this throttle, as I decrease the resistance, we see that we are getting an increase, and it should go all the way up to 4.5 volts just about, and it does. And then all the way back down. So we can see that we can now verify that we have not only a good 5-volt reference once again, which we knew before, but also that we have good ground and good signal wire continuity to the computer. So at this point, we've basically tested everything there is to test on a TPS. If we still have some kind of issue, then it's most likely some mechanical issue in the throttle body, or it is what's called a referenced code. In other words, the computer thinks the TPS is at fault when actually something else is, and we'll talk about that pretty soon. Now, you'll notice there is a major disadvantage with this method over the scan tool, and that is the numbers can be kind of jumpy, and it would be a little bit harder to find a dead spot. Really, for this test, to look for dead spots, the best way to do it would be to use some type of graphing multimeter or an oscilloscope, and I do not have an oscilloscope. So a lot of you have mentioned that of all people I should have an oscilloscope, and I would love an oscilloscope, I am not going to lie, but I've just never invested in one. But man, if I had an oscilloscope, I'd be playing with that thing all day. It would be like I had a second penis.